Good afternoon. I'm going to present the BEP for the NAICM. Does anyone here knows what is a BEP? Right. Well, what I'm going to talk about is the experience of how we created a BIM execution plan for the NAICM. The NAICM is a Nuevo Aeropuerto Internacional de la Ciudad de México. It's currently the most important airport infrastructure design in the West Hemisphere and the first LEED Platinum version 4 airport in the world. The project consists in more than 5,000 hectares, and therefore creating the BIM model for the whole project consisted a whole challenge, and we only had 1 year to develop the whole project, so that was a really great challenge. The terminal project was designed by Foster & Partners and Free, and I had the chance to be part of the rest of the whole infrastructure as well. So just to give you the idea of the sizing of the project, as I said, is 5,000 hectares. We had more than 50 buildings and structures, various kilometers of utility systems, and in my experience, I've been a BIM manager for around 5 years, and this has been one of the largest models in my experience. Just to give you a sense of the size of the building, this here is Musée du Louvre in France. This here is a Metropolitan Museum in New York, and this is the size of the terminal. It's more or less 1.5 kilometers long from north to south, and we need to develop the whole model of what the red dot is indicating here. So first, in order to create this BIM execution plan, we needed to understand the organizational structure. Our client was Grupo Aeropuerto de la Ciudad de México. We had a PMO, which was Parsons. The master plan was Aeropuerto. The terminal building, as I said, and the air traffic control tower was designed by Foster & Partners and Free. And I was part of TESANA, designing all the auxiliary buildings, air aprons, utilities, and runways. And well, the client was in Mexico. Parsons was half Mexico, half US. Arup was in the UK. Free was part, Free and Foster was part in the UK and part in Mexico. At TESANA, we were 3 companies. One was in Mexico, the other one was in Netherlands, and the other one was in Mexico. So that represented a huge challenge. And when you're creating a project and a model so large with so many companies involved, who establishes the model standards? So in this particular project, I have to explain to you, there was no BIM protocol at the beginning of the project. So Arup started the design of the master plan with no BIM scope on them. So that means that there was no model designed by them or anything else besides this DWG. And on January 2015, Parsons got involved in the project as a PMO, and they created a BIM model, Lot 100, which means this model you see on the image here, but that was based on common practice, but not on standards. Who said that was Lot 100, and how can we establish that that was the information we needed to start the project? So then Foster and Free started also the design of the terminal building, but they didn't deliver any BIM models until 2016. So that means that the ones that needed to establish those standards, it was us, TESANA, and we needed to establish our own standards, and therefore, since it will be the first models, it will be the standards from everyone else. Okay, so the first step was, everybody knows this chart. It's a very famous chart on how to establish a BIM execution plan. Be clear, be simple. You have a BIM goals, uses, BIM per execution project, process, and information exchange. But what is clear and simple for different cultures? And here I can tell you, for example, in Netherlands, they have different software they commonly use. We have different software that we use in Mexico. And also, there was a lot of architects involved doing buildings and a lot of engineers designing urban areas. So how do we manage to be simple and clear at the same time with all these implications? The step 2, we needed to understand the contract and the scope of its phases. If you see here, there are different areas of the contract. We have to design buildings, civil structures, utilities, surface activities, all those things. And within Tesana, we were 3 companies, and each one was designing different phases of it. So we needed to know what kind of information will be delivered in each of the phases of the project in order to communicate in the best way possible. So in this case, the designer was NACO, which was a Netherlands company, and SACMAC, which was a Mexican company, and TATCO, which was a project manager within Tesana. The step 3 was to setting a common data environment. You know that the importance of setting a common data environment is to create a single source of information, a single source of truth. So for the client, it was clear to have that platform. They used Aconex in order to provide that information. All the companies involved had to input all the information through Aconex. But at the same time, we as company, we needed to provide our own common data environment in order to avoid creating misunderstandings in between the companies. And that was when we chose Vault, and I'm going to explain that later. That was our source of truth. Step 4, choosing the software. For architecture, we based our information on universities. We needed to have a lot of modelers available in the market. So that's why we chose Revit, because it was easier to find during that year that's gonna last the project modelers in Mexico that know how to use Revit. For civil design, it was easier to use Civil 3D. We compared, as you see, with different other solutions. And for the model checker, we decided to go for Navisworks since it's the one that has more interaction with both programs. So at the end, we brought all these together into Vault. At the same time, we chose Vault as a common data environment since it was the only solution that gave us the possibility to share also PowerPoint information, Word documents, PDFs, and Excel documents as well. So that was basically how we chose the software. Then stating the LOD for phases by discipline, that seems quite simple when you see at this chart. But we're talking about at least 12 different disciplines in between civil design, MEP, BMS, architecture. So according to who is that LOD and in which discipline? So the first thing that you have to understand is which standards will apply. There are different standards that are in the market available for everyone right now. For example, the AIA in America has its own standards. The BSI in the UK has its own, and there's BIM Forum, which is more like an international standards. So we have to choose from one of them in order to create standardized modeling. And contractually, we had to establish the LOD to the client for our deliverables. So it is very important to understand this because the level of detail is how to establish to all the disciplines how they have to work and what information they have to provide in order to make them work exactly the things that you need at the phase you are working on. Because then, if you don't do so, you will work more than needed. And that's why we have to establish these spreadsheets with all the information by each of the disciplines. You can see here architecture, MEP, civil work, land works, civil MEP, all the engineering was established by these standards, and we can see graphically what information will be in which phase. Then step 6, how to exchange information. This is very important. As I mentioned before, Arup sent the DWG via Aconex. Then we brought it into Vault. Then each of the departments, for example, the architectural department and the civil department, take that information, they share it through its own software, Revit in this case, and Civil 3D. They start developing the design of the project. They bring it together into Navisworks all together. Then we understand the clashes and all the implications of all such designs, and they bring it back together. They have to do all the rework and then share it through Aconex via IFC. So this is the best solution in our experience, not because of the software can use anything else, but in our experience, because at the end, the IFC file is the one that has to be shared in order to give the chance to the client to choose any other solution that they may want. How to exchange the information. At the beginning, you have to set up the units, the coordinates, and the altitude. This is very, very important because engineers and architects talk different languages, and sometimes they are talking about inches or meters or different kind of coordinates. So we needed to check for that information at the beginning and start creating a project base point.
I'm sorry, if you could.
Yeah, sure. Then how to evaluate information. First, you need to understand what information will be evaluated. With the standards, you understand the LOD that you're working on, and you check what information has to be reviewed. You bring the information into any software, but not with its own properties, but IFC properties in order to be checked in the model checker. And then in the model checker, you see that the information is there. That's how you have to check the information. And also when to start the clash detection. You have to program a specific time in order to create the clash detection, and you never have to start too early and never start too late, and also always have to plan a clashing correction hours. That's something you always have to plan because it takes you too long, and if you start too late, it's gonna take you more time. And also you have to consider what is a clash, because there's no standards for tolerance in this. So that has to be very clear established on the beam execution plan. So on our experience, less than 2 inches in a pipe is not a clash, because that can be solved on site, easy, and it doesn't represent too much cost. But more than 2 inches is definitely a clash, so you have to change those things. Yeah, finally, our BEP ended up being the beam protocol that never existed. It included 6 chapters. I don't recommend it to be that long, because it included also later standards, LOD for Revit for each of the parameters, and a file naming system. So you can see here an animation of the whole model here that we ended up having. You can see all the MEP from terminal with all the detailing that we ended up having for those are the fire stations, and all the civil works included, all the terrains, everything else. As a conclusion, we all know this chart. The problem with not having the beam execution plan is that you don't know what happens in these areas. When the detailed design is given to an analysis or a documentation and then to the fabricator in order to provide the information, you don't know how they're gonna need it. So that's why you have to establish those standards. And the conclusions are that every single project must have a BEM protocol as part of the OPR. The protocol should always establish an open BEM standards, especially in large projects. In a small project, the first designer involved should advise the clients and create a BEM protocol, and also it should be part of everyone's contract. In a large project, the client, in conjunction with the PMO, should always establish the BEM protocol, and it should be part of everyone's contract. Every office should establish its own BEM execution plan for each project to include the specific dates, phases, and deliverables. The BEM scopes, phases, and deliverables should always be clear for everyone, especially the clients. And the added value of the models come with very clear BP and BEP, BEM protocol and BEM execution plan. And this is the most important. The BEM